Today's video starts in my living room. And specifically it starts with these two speakers. These are a pair of Klipsch Forte 2. They're kind of vintage, but they're not just any pair. These were signed by Paul Klipsch himself. And apparently Doug and Paul knew each other, and these were custom built for Doug. These were inherited. They sat in storage compartments and in basements for way too long, not being used. And eventually the question came up like, you know, we're not really doing anything with these. Tom, would you like to have these? And I was like, I guess, I mean, they don't really fit anywhere, but I'll make them work, and these are the nicest speakers that I have ever owned. Doug, who originally owned these, was a jazz music collector. He had a huge collection of LPs, and from what I understand, these were slightly custom made to tailor his taste. The first time I turned them on, they were pretty harsh. The tweeter was way louder than it needed to be. That was an easy enough fix in my Yamaha. You know, for movie watching, you know, that's a TV. These could also use a bit of low-end extension, aka a subwoofer. As a proof of concept, I built this guy. This is a roughly 60-liter ported woofer that's not gonna win any beauty prizes, but it was a good proof of concept for just how I needed to tune this thing and how it was gonna perform. And because I've already got this mix of old and new, which is quite the contrast, I thought, hey, why not replace this with something that is gonna be just as contrasting? So we're gonna build a space-age design subwoofer from, you know, presumably eco-friendly materials today. This guy wubs pretty hard when he needed to. And we're gonna build this right after a message from today's sponsor. Behind me, we've got part of my 30 kilowatt solar system that I planned myself. And while that was already quite a lot of work, once you have to plan out larger solar farms or industrial scale roof mount installs, the hand waving I did for the couple panels here just isn't gonna cut it. PVCase takes in location and terrain information and automatically creates optimized layouts, 3D cabling, and BOMs for your next large-scale ground or CNI roof mount solar project. And it's all running inside AutoCAD for that familiar engineering touch. Check out PVCase at the link below. I've had a trip to the home center and I've grabbed a couple of things that we could use for this. First of all, plaster. This is just regular plaster. I've got some fiber reinforced concrete. Google tells me this is called screed, basically just a concrete mix. This is some raw cement, pure cement, as well as some quartz sand that we can mix up with this stuff to create our own mixes. Now, plaster and cement don't mix. I had tried to get lime because that was the original idea, to do Hempcrete, which is hemp plus lime. But first of all, that would have taken about a month to set up, and also it would not have been airtight or particularly strong. I'm still going to try and use some natural reinforcement fibers. So I've had a stroll through this one's upside down. I've had a stroll through the rodent and pet section, and I've grabbed some straw, which I'm gonna make a couple mixes with and try to use this as a fiber reinforcement, as well as some shredded hemp fiber. I'm gonna try to mix this with cement or with plaster and see if this works out and gives us any extra strength. Before I commit to doing the whole project with one of these mixes that I've dreamed up, I'm gonna do some test pieces in these IKEA drawer separator things. These are all the same shape. I've given them a good waxing with some mold release, the same stuff I used in the last video with the carbon fiber. And we're just gonna see if any of these mixes are usable and if they're any good, any strong once they're hardened. I'm gonna mix some of these up and I'm gonna test them in a week. Looking at these, all the plaster stuff is already pretty much fully cured. I mean, these are nice and warm. These are going to take some extra time to fully set up. Some of these were a bit of a pain to work with. For example, the straw. It's just way too large fibers. But if this stuff ends up being super strong, I might end up using it as a reinforcement layer. Other than that, I did prefer working with the plaster-based stuff. It's just less mess. It's not as aggressive, and it does harden up a lot faster, which means I don't have to wait as long for everything to get to a usable state. With the cement-based stuff, this stuff is all pretty mushy still, and I think it's just mostly see the fibers soaking up some of the water, so this isn't really setting up yet. It's been a bit more than just a week. It's been more like 3.5 or 4 weeks, and these parts are now 100% cured and dried. So let's get these demolded, have a look at them, and then we're gonna break them. Glossy concrete parts. That's something to look at. The parts that have like the ugly surface on the top surface where they dried off with the hemp fiber plus plaster of Paris, these look perfectly fine on the inside. So that is a very usable surface, and I do kind of like the texture that it gives it. One thing that I'm really noticing is that these parts with the hemp fibers in them are significantly lighter. So these are all around 500-600 grams, both with the cement and the plaster, and then the ones that is just pure fiber reinforced concrete is twice as much. So that is going to be a factor in how practical these materials are going to be, because the subwoofer I'm building is going to be quite big. It's going to be a 60-liter volume, which means there's going to be quite a bit of this stuff. And if it ends up being, 100 kilograms just for the case, then yeah, that's not going to work out. Smooth plaster. That also looks very, very nice. Okay, I may have drastically underestimated how strong this stuff is, because at 20 kilograms of load out here on a half-meter lever, just the pure plaster already isn't budging at all. Well, before I wreck myself trying to break the plaster, I'm actually gonna try one of these hopefully weaker hemp cement parts, and if it also doesn't break, then we have a problem, but if it breaks, then at least we have some comparative data. So here's our results, and I don't think we need to look at the exact numbers. Anything that had the hemp fibers in it failed at around 3 kilograms, while the fiber reinforced concrete and the straw, surprisingly, lasted to about 20, and I could not break the pure plaster. But these are still usable. The fact that they are much, much lighter than the solid parts, I think that alone makes them worthwhile. I'm going to use a mix of the plaster materials, and I'm going to skip all the cement stuff. I just don't like working with cement. It's just such a messy, nasty product. Okay, let's go make a mold for this. So let me give you a real quick overview of what the CAD process looked like for this project. I'm not going to go into too much detail, but there is one learning in here where, once you wrap your head around it, it feels like you're unlocking a new superpower, because it allows you to do so many more things. And that superpower is surface modeling. All I created for the original reference shape is the shell that I'm worrying about. Because I'm making molds, I really only need this surface that I'm then applying my plaster mix to. So that's all I need, and it allows you to think about the way that you design your parts differently. You don't have to worry about thicknesses, about cutting through stuff. You're really just worrying about, what are the defining shapes of my finished part. So I've got these splitters here that split my mold shape into one handleable piece. I've got this feature here, which is the bottom splitter. There we go. That splits our darker from the lighter part, and I'm gonna mold those separately. You just open this third eye about how you're thinking about parts. And yeah, I would really recommend trying it out, giving it a shot. And if you do, pin the split body tool to your quick bar, because that is really what enabled me to do what I did. It allows you to cut bodies or other surfaces with a new surface. So I use this to cut this off right there. That is the best tool ever. And yeah, give it a try. Let's check out what parts I made from it. All right, there's our parts. Now, you might be able to tell that these have like all different colors and stuff, and that's because I used up all the little, filament spools that had 100 grams or something left on them. This was a good effort of just getting rid of all those little scraps. Yeah, let me lay these out, and I'm gonna walk you through what we've got here. So getting all these parts laid out and split up in ways that they fit on a print bed, and so that they would be removable once we've got our material in here, that was definitely the trickiest part in here. And you're gonna see how these go together in a bit. But one thing I want to show you that I found was really cool is these dovetail joints that Prusa Slicer can generate. So essentially you just export a single STL. This is all one file essentially. You load it up and you say, hey, I want to split it here. And you can choose if you just want a straight split or a dovetail generated like this. With a bit of adjustment, these fit together basically with no more of a lip than the individual layer. With the larger part like that was not an option because the splitting tool still has quite a few limitations. But for these simple parts that can remain together and stay as one part essentially, that's really cool. I'm gonna get everything assembled. Some of these parts need to be glued, some need to be screwed together, and yeah, I'll check back in once that's all in shape. Alright, so that is the mold for the lower part completed. This inner ring is going to stay together, so it's going to get glued to the OSB. But this outer ring I'm going to have to remove to unmold it, to demold this, because this is sort of an overhang. And especially these two blocks are not going to be easy to remove just by pulling our molded part out, because you know this severely overhangs. That's the insert for the port. And this is for the electric, so the cable pass through is going to get inserted here. So yeah, I'm going to glue this center piece down, and then these only stay screwed to this bit. But it's already feeling quite rigid and quite substantial, but it still needs to stay flat, so that's what the OSB does. Now this mold for the centerpiece for the side just needs to get glued together. This is just, you know, butted together, that's it. However, the sides where I have, you know, one set like this and then one mirrored, these are a bit more complex. These have the dovetails in them and that really helps align them. So these get fixed together permanently as one buck, then the other half. And then again, we've got 5 screws, 5 M8 screws that hold these together like that, because, you know, this needs to be removable once we've got our mold done. There's an undercut with this lip, and I think these thrusters might also be hard to unmold if I don't have this part removable. So these parts have had overnight to harden up and cure, but of course with the layer structure and all the seams still very visible in here, molding stuff into this is going to imprint that layer structure in the parts as well. So we're going to need to fill that in as well. And for that I grabbed this dollar store modeling paste, which is kind of like a mayo consistency. Yeah, that's nice and thick. And I did a little test and pre-run with it, and I'm gonna sand this down and just see how well this comes out and how smooth it gets. Okay, so it does smooth out very nicely, but you do need to apply quite a bit of it and then sand all the way through to the plastic. I'm gonna slather up all the parts in this paste, and then it's another day worth of drying. I know it doesn't quite look like it, but this is actually the majority of the work already done. At this point, we are almost ready to cast parts into this and to go into mass production if I so wanted to. I'm not going to, but I could. Let's get these sanded down and let's get some final parts made. Okay, so that was a lot more chaotic than expected. The plaster started setting up real fast this time, but I think I did get into all the spots that I needed to be in. I am starting to realize that I should have thought about demolding a lot more than I did. The glass fiber mesh that I put in should help compensate for the fact that I have no idea how thick I actually made this layer. There's no indicator how thick any of these pieces are, but that mesh should really help strengthen this up. So this is now just rinse and repeat. I'll see you when all these parts are done. So that is most of the parts taken out of the mold, and they did come out nicely. This one I somehow messed up the mixes. The lid still needs to come out, and of course the base is over there. And it did go pretty well. Demolding this went very, very smoothly. But yeah, on the same token, I'll be the first to admit that these parts didn't really come out perfectly. There is some pitting there where it just missed material. That's just what happens when you have difficult geometry. Overall, I think the surfaces came out very nicely and the parts are very serviceable where you're gonna see them, like this inside you're never going to see. And I think we can just get away with calling this space damage, I think? Yeah, that's what I'll go with. So this is our 1 kilowatt amplifier that's built in here. It's probably more like 200 watts sustained looking at the components that are on here, but that matches up pretty well with the driver, with the chassis that I put in here, which is also around the 200-300 watt range sustained. Again, more than enough. I am starting to realize that it is going to get pretty heavy once all the shell parts are installed, so I'm going to take this upstairs and assemble it in place, because there's no way I'm going to be able to carry the entire thing up and down the stairs. While this thing is still open, this part is functional. This is the actual speaker. But once we close it off, once we put all the side panels on, if there is something wrong with the wiring or the electrical or whatever, fixing it is going to mean breaking the entire thing. So I would rather give this a quick test run now, and then we can close it out for good. Oh, I think I just heard a little startup click. Yeah. All right, there is definitely some wubs coming out of this, so that means we're free to move on and install all the paneling and get this thing buttoned up. I'm also eventually going to tie my mini DSP into the loop for the subwoofer, because this entire enclosure is designed to work best with a DSP. So while you weren't looking, I touched up the base reflex port just a bit. There was an ugly white glob of glue there. I just used some black paint because in the original this is an engine port outlet, so it makes sense that this is sort of burnt and charred, and it just helps hide that ugly glob of white. But if you look at the overall appearance of the enclosure, it is pretty apparent that the individual panels look quite different, and that is simply because this guy is a lot more wet still than this one. This is just 1 day of extra drying. If you compare that to the sample that we did before all this casting, this part is the exact same mix but is fully dried. That is how that is going to look finally once everything is fully dried. But also it kind of looks like we're starting to get that bleed through from the fibers that we also got in the sample parts. And if that becomes an issue, I can just paint the entire top portions because, you know, this is plaster, which is super easily paintable. But for this montage, I'm just going to use some editing magic and I'm going to make these panels look the same and look like they are fully dried. So, how does it sound? Well, I've now got it hooked up to the DSP and it sounds, well, exactly like the old one, which was the entire point of building the prototype and then putting it into a, you know, something that I put a bit more effort into. So on that front, full success. I am gonna admit it is not perfect. Like the plaster process, there are some flaws with it, but what I am kind of proud of is that it didn't take any shortcuts just to get it done in time for a video. So I did give this the time that it needed because, you know, I will be using this every single day and I don't want to build something that is going to annoy me every day. So on that front, I think I also very much succeeded. Plus, you know, nobody else has a SpaceX Dragon capsule subwoofer that's like as tall as me sitting down. So this, I think, as it turned out, is a pretty cool, unique piece. If you have any questions about this process, for example, about the CAD for doing the mold, because it's the same process that I used for the carbon fiber parts, leave a comment below and I can see what I can do for a follow-up video. The next couple of videos are again going to be a bit more 3D printing specific, so stay tuned for that. Subscribe, maybe. But in any case, hope you learned something, hope you found this interesting. Thanks for watching, keep on making, and I'll see you in the next one.